In this video, I'm going to talk about expectation of both discrete and continuous random variables. Expectation basically means mean, okay? And we use mu as a notation. There is one more notation, that is capital E and X in the bracket, okay? So these two notation we use for expectation. Now if you remember, in high school we used to calculate mean using frequency. So there used to be 3 columns, one for X, another for frequency, and another for fx, that is the product of frequency and x. And then we used to sum all the values of fx and then divide it by summation of frequency, and this gives mean, right? But now we'll replace frequency with probability. So the first column will remain same and the frequency is replaced by the probability, and now we'll multiply x with the probability, and then we'll sum all the values of probability and x. So this is summation of x times probability divided by the summation of probabilities. Now summation of probabilities is 1, right? So this is 1. So expectation of a random variable is simply summation of x times probability. All right. So this is for the discrete. Now for continuous random variable, the expectation of x is simply x times function, and then we'll apply the integration. So the summation is replaced by integration and probability is replaced by the PDF. So that's the only difference. Now if we have to calculate the expectation of x square, then we simply replace x with the x square and then probability. Similar in the continuous random variable, x will be replaced by the x square and then PDF. Okay, so this is expectation of x square. So in general we can write expectation of x to the power r is summation of x to the power r times probability, and in continuous, integration x to the power r PDF and then dx. Not just this, if we have a function inside the bracket of expectation, then we'll replace x with the function, okay, and then the probability. Similarly, in continuous random variable, x will be replaced by the function and then PDF and dx. Okay, here will be the limit of x. Now let's look at the some properties of expectation. So properties of expectation. First property is expectation of a constant is simply constant. Now you can see this as the mean of a constant, okay? So the mean of a constant is basically the constant. So for example, if the constant is a, then the expectation of a is simply a. All right, and this is very easy to prove as well. You can write expectation of a as summation a times probability, right? Whatever is in the bracket of expectation, will multiply that with the probability. So this is we can take a outside of the summation, because a is constant and the summation of probability is simply 1. So this is a times 1 is a. All right, and similar is the proof in continuous as well. You can simply replace summation with the integration. Now the second property is, if constant is multiplied with a random variable, then we can take constant outside of the expectation. And this proof is again very simple. Expectation of ax, we can write summation ax times probability. We can bring a outside of the summation, and this is nothing but the expectation of x. All right, now third property is, suppose expectation of ax square plus bx plus c is given, then we can separate each terms. That is expectation of ax square plus expectation of bx plus expectation of constant. Now we know we can bring constant outside of the expectation. So this is a times expectation of x square plus b times expectation of x, and expectation of constant is just the constant. So these are the properties of expectation. Now let's do one example. So suppose a random variable x has some distribution, has some probability distribution. So suppose the points are -2, -1, 0, 1 and 2, and probabilities are 1/6, p, 1/4, again p, and 1/6. Now you are asked to calculate the expectation of x of this random variable. So one thing you can note here is that whatever will be the expectation, that will lie in between -2 and 2. So this is the checking point. If you get the expectation something like -3 or 3, then your answer must be wrong, because expectation must be in between -2 and 2. All right, so that's the checking point. Now first we need to calculate the value of p, then we can calculate the expectation. So to calculate the value of p, we can simply sum the probabilities and equate it with 1. All right, so this is simply 1/6 plus p plus 1/4 plus p plus 1/6, and this is equals to 1. So when you solve this, you'll get p equals to 5/24. Okay, so you get the value of p. Now you can calculate the expectation. So expectation is simply -2 times 1/6 minus 1 times, what is the value of p? P is 5/24, and then 0 times 1/4 plus 1 times 5/24, and then 2 times 1/6. Okay, so I leave this calculation to you. I hope you can solve this. Now let's do one more example. Suppose you are given a function probability density fx equals to 2 times 1 minus x for x is greater than 0 and less than 1. So you can see you are given a range, range of values. So this is continuous random variable. That's why this is the PDF, that is probability density function. This is not the probability distribution function. Okay, this is probability density function because the range of the values are in range and 0 elsewhere. Now the first question is, so that expectation of x to the power r is equals to 2 times r plus 1 times r plus 2. So this is the first question. So let's do this first, then we'll move on to the next question. There is one more question. So we know the expectation, whatever is inside the bracket, will be multiplied with its PDF, right? And since this is continuous random variable, so we'll use the integration, and the range is 0 to 1. Okay, and the inside the bracket we have x to the power r, and PDF is 2 times 1 minus x, right, and dx. Now we need to solve this integration. So we can separate 2, that is constant, 0 to 1, x to the power r, 1 minus x dx. Now you can solve this integration using other methods, but here I want to show you some other methods which we can use frequently while solving some other problems, and this is a kind of trick. Okay, so let's learn a new integration first, then we'll solve that question. Okay, so there is something called beta integration. So it has a form x to the power a minus 1 minus x to the power b minus 1 dx, and the range is 0 to 1. So if integration is something like this, then our answer is gamma of a, gamma of b divided by gamma of a plus b, and gamma of a is a minus 1 factorial. Okay, so let's do one example. Suppose the function is x cube 1 minus x to the power 15 dx, and the range is 0 to 1. So now we can convert this in the form of beta integration. So the range is 0 to 1. We can write x to the power 4 minus 1, which is 3, and 1 minus x 16 minus 1, which is 15. Okay, so now this is in the form of beta integration, so we can apply beta integration. All right, so our answer is 4 gamma, and then gamma 16 and gamma 20, right? So this is 3 factorial times 15 factorial times divided by 19 factorial. All right, now let's go back to our previous question. Now in this question we can use the beta integration, so we need to make slight changes so that the function looks like the beta integration. The range is okay, that is 0 to 1, which is fine, but inside we need to make some changes. So we can write x to the power r plus 1 minus 1, right? So r plus 1 behaves like a, right? And then we have 1 minus x, this is, we can write 2 minus 1 and dx. So now this looks like a beta integration, so we can use the formula. So this is 2 times gamma r plus 1 and then gamma 2 divided by gamma r plus 3, right? Now let's solve this. this is 2 times r factorial times 1, right? So we don't need to write it. And then this is r plus 2, r plus 1, and then r factorial, right? So you can cancel this. So this is 2 divided by r plus 2 and r plus 1. Okay. So this is our proof. Okay. This is done. Now let's do the second part. So the second question is, use the result. So use the above result to evaluate expectation of 2x plus 1 whole square. So we need to use the result to evaluate this expectation. So first, let's simplify this little bit. So we can we can simplify the inner expression, that is whole square. This is simply 4x square plus 4x plus 1, right? And then we can bring the constant outside of the expectation. So this is 4 expectation of x square plus 4 expectation of x, and then the expectation of 1 is simply 1, right? Now we know the expectation of x to the power r is 2 divided by r plus 1 times r plus 2 from above result, right? From here. Now we can put r equals to 2 to get this expression. So x to the power 2, so this is 2 plus 1 3 times 2 plus 2 is 4. This is 1 over 6. Similarly, we can get ex by putting r equals to 1. So this is 2 times 3, right? This is 1 over 3. So 4 times ex square is 1 over 6 plus 4 times ex is 1 over 3 plus 1. Okay. Now I leave this calculation to you. I hope you can get the correct answer. Now let's move on to the variance. So what is variance? Variance measures the spread of the data from the mean. So this measures the spread of the data from the mean. Notation that we use for variance is VAR and capital X, that is random variable X, or we simply write Vx. Sometimes we also write sigma square. Okay. So we have a formula of variance, which is expectation of x minus mu whole square. So you can see random variable represents data, right? So there is a difference between mean and random variable x. So it measures the spread of the data from the mean. Now we do not use this formula directly while solving the questions. We use the simpler version of this formula. So let's simplify this little bit. So let's simplify the inner expression. So this is x square minus 2x mu plus mu square. And now we can separate the terms. So expectation of x square minus, now 2 mu are constant, so we can bring this outside of the expectation. So this is 2 mu expectation of x, and expectation of constant is just the constant. So expectation of x square minus 2 mu. Now we can write expectation of ex equals to mu, right? So this is mu square plus mu square. So now this is expectation of x square minus mu square, and we can write we can replace mu with expectation of x, and this becomes whole square. So this is the simpler version of this formula, okay, and we'll use this formula while solving questions. This is simple to use, okay. Now let's look at some properties of variance. So properties. So the variance of constant is 0, okay. So constant means the fixed number, so the fixed number means it cannot change, right? So the variance is 0. Now second property is variance of a constant with the random variable is, now we can bring this constant outside like the expectation, but this will come out, you know, with a square on its power, that is a square and then vx, okay. And third property is variance is always positive, it will never be negative. All right, so these three are the major properties. And again, whenever there is the long expressions, we can separate the terms like the expectation, and if there is constant, we can bring it outside of the variance with a square on its power. All right, now let's do one question of the variance. So suppose you are given a function fx equals to half times x plus 1, and the range of x is greater than -1, less than 1, and you are asked to calculate the variance of x, okay. So we know the formula of variance, that is ex square expectation of x square minus expectation of x whole square. So we need expectation of x and expectation of x square in order to calculate the variance of x, right? So let's first calculate the expectation of x. So what is the expectation of x? This is simply x times PDF, right? And PDF is half times x plus 1. And what is the range? Range is -1 to 1, okay, dx. Now we need to integrate this. So this is simply, we can bring the constant outside of the integration. This is -1, 1, and then we can multiply this x, inside the bracket. This is x square plus x dx. So now this is x cube divided by 3 plus x square by 2, -1 to 1, okay. Then we can put the value. This is 1/3 plus 1/2 minus -1/3 plus 1/2, right? And if you solve this, you'll get 1/3, okay. So we got expectation of x. Now we need to calculate expectation of x square. The expectation of x square is simply, we replace x with the x square in the integration. The range will be the same, x square half x plus 1 dx, right? We can bring half outside, and then we can multiply this x square inside the bracket. This is x cube plus x square dx. Okay, so this is half x to the power 4 divided by 4 plus x to the power q divided by 3, minus 1 to 1. And now you can substitute the values, 1 over 4 plus 1 over 3 minus, this is 1 over 4 minus 1 over 3. Okay, and you can solve this, you'll get some answer. Okay, and then suppose this is a, I don't know the answer, you can calculate this. Suppose this is a, then the variance will be expectation of x square, which is a, minus expectation of x whole square, which is 1 over 3 whole square. Okay, so you can solve this and you'll get the variance of x. All right, now let's learn transformation. So there are two different types of transformation. One is through PDF, okay, and the other is through CDF. So first let's look at let's look at through PDF. So suppose you are given a function fx equals to 6x times 1 minus x, and the range of x is 0 to 1, greater than 0, less than 1, and the transformation is y equals to x cube. Okay, and you are asked to calculate the PDF of y. Okay, so this is the question. So you are given the PDF of x, so you can write 0 to 1, which is the range of x, and the PDF, that is 6x 1 minus x dx, and this will be equal to 1, right? Because the integration of the PDF will be equal to 1. So now you need to differentiate, you need to put the value, you need to put the value of x in terms of y, so that everything inside gets changed into y, and we also need to change the range. Okay, and then whatever will be inside the integration, that is equal to 1. This means the function inside the integration will be our PDF in terms of y, right? PDF of random variable y. So let's do it. So let's see what is the replacement for dx. So we need to differentiate this transformation. So this is x cube equals to y, so we can write x equals to y to the power 1 over q, right? Now we can differentiate this, dx equals to 1 over 3 y to the power minus 2 over 3, right? 1 over 3 minus 1, which is minus 2 over 3 dy. So instead of dx, in place of dx, we can write this thing. Now what about the range? We need to change this range as well. So we know y equals to x cube, so we can put the value of x. So initially it is 0, so when you put the value of x equals to 0, so then y is 0, right? And when you put x equals to 1, then y is 1. So there will not be any change in the range. Okay, now we can substitute the value of x in terms of y. So there is no change in the range. 6 will remain as it is. And what is x? X is y cube 1 minus y cube. And what is dx? Dx is 1 over 3 y to the power minus 2 over 3 dy, and this is equals to 1. Now this is equals to 1, this whole thing is equals to 1 means this thing should be the PDF of y, right? Because the integration of the PDF is equals to 1. So this should be the PDF of y. So when you solve this thing little bit, you'll get the PDF of y equals to 2 times y to the power minus 1 over 3 times 1 minus y to the power 1 over 3. And please do not forget to write the range of y. So the range of y is simply 0 to 1. So this is 0 to 1. Okay. So this is how you can transform the PDF of x, to get the PDF of y. So this is the transformation through PDF. Now let's look at the transformation through CDF. So through CDF. So suppose you are given the CDF fx equals to x cube 8. We can also write the another notation, that is p x is less than or equal to x, right? And the range of x is greater than or equal to 0, less than or equal to 2. And transformation is given y equals to root x, square root x. Now you are asked to calculate the PDF of y. Okay, so we'll go through the CDF, okay, because this is the transformation through CDF. So we'll find out the PDF through CDF. So we know the CDF of y is simply y, random variable y, less than or equal to small y, right? Now this random variable, because this is also the random variable, right? These are random variables, so we can replace y with square root x. So this is square root x less than or equal to y. All right, now we can remove this square root. So this is simply 1 over 2, right? Square root is simply 1 over 2. So we can square on both sides, then this will become square, right? So this is x is less than or equal to y square. Okay, now we know that the CDF of x is x cube divided by 8. So we can replace x with y square. So this is simply y to the power 6 over 8. All right, so we got the CDF of y, that is y to the power 6 divided by 8. Now in order to get the PDF, we need to differentiate the CDF. If you want to get CDF from the PDF, from PDF to CDF, we need to integrate. But from CDF to PDF, we need to differentiate. Okay, so here we have CDF. So from CDF we need to go to PDF, right? So we need to differentiate this. So the PDF of y becomes 6 times y to the power 5 divided by 8. And please do not forget to write the range. So the range is 0, less than or equal, greater than or equal to 0, less than or equal to root 2. All right, so this is how you can transform the function through CDF as well as through PDF. Okay, now let's stop here. In the next video I'll talk about the different types of distributions, and then we'll calculate the expectations and the variance of different types of distributions. Okay, so thank you so much for watching this video.